Hi students. Now let us see an example on bitwise operators. What are the bitwise operators we have? This is the bitwise AND. So next bitwise OR, bitwise exclusive OR, and bitwise left shift, and bitwise right shift. So these 5 OR comes under the bitwise operators. So we can perform directly on the bits with the help of these operators. Like if you enter the something 4 and 2. So in the bitwise AND, what happens here is, so like if my inputs is 0, 0, 0, 1, 1, 0, and 1, 1. If I perform the bitwise AND operation, since 0, 0 is 0, 0, 0, this is the 1. And OR is if any one is true, then true, remaining all are false. Then exclusive OR. If all are equal, okay, then if all inputs are equal, okay, in the exclusive OR, then the result is 0. In the remaining places, the result is 1. So like this, with the help of this fundamental rule, I perform the operations under these values. So here 4 equal to how much in the binary? It is 1, 0, 0, and 2 equal to 0, 1, 0. And I perform the AND operation here. Okay. So according to the AND, what is the condition? If all our inputs are high, then the output is high, nothing but a 1. So here, all inputs here 0, 0 means 0, 0, 1 is 0, 1, 0 is 0. So this decimal value is 0. So it's printing 0 here. Okay. Whereas if you perform the OR operation, so 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1 is 1, 1, 0, 1. So how much its value is? Its value is 6 in the logical OR operation. Okay. And when you perform the exclusive OR operation also, 0, 0, 1, 1. No 0 zeros. So 0, 0 is the 0 in the remaining places 1. This also you get 6. Like this, I can perform the logical and bitwise and bitwise OR and bitwise exclusive OR using these fundamental rules. Now see the left shift. So what is meant by left shift here? So 4 value is the 1, 0, 0. This is called LSB bit. This is called MSB bit. Okay. So I'm writing 4 left shift 1 means nothing but you shift this 1 bit to the left side and this bit to the left side. So what happens then when you shift that one? So 1, 0, 0, and this place will become again, it will become 0. Okay. A new place again, it is occupied by the 0 here. So this is how much value inside the in the decimal. So 2 power 0, 2 power 1, 2 square, 2 cube. It's nothing but a 8. So I am getting 8 when I shift the bits to the left hand side. The same way, when you shift the bits to the right hand side, 4 right shift to 1, nothing but what do you do? So you shift this bit to here and this bit to here. Then it will come like this. So 0, here it will come 1, and this is the 0. So this is also again 0. So what is the value in the decimal? This binary value is 4. Sorry, 2, 0, 1, 0. So 2. So means when I shift the 1 bit to the left hand side, that is nothing but a 4 into 2. I'm getting the value 2 here. When I shift the bit right hand side, 4 by 2 is nothing but a 2. Okay. So shifting left side is nothing but a multiplying that number by 2, those number of the bits. And shifting right side is nothing but a dividing the number by 2, those number of the bits times. If I write 4 left shift 2, this is nothing but a, you multiply this number by 2 times. So 1, 2. So my result will be obviously 16. Okay. So this indicates here number of bits. So number of bits times you multiply by 2 in the left shift. In the right shift, you divide by 2. This is how do I perform the operations using the bitwise operations. Let's take other values, something 5 and 2. Okay, I have taken directly values like 4, 2. So it's giving the result